Let's talk about joint variation. When a quantity varies directly as the product of two or more other quantities, we say it has joint variation. Our working equation for joint variation will be y is equal to kxz, where k is the constant of variation. Notice this time we've got two things that we're multiplying the k by in order to determine what our y is going to be. Let's look at an example of joint variation. If y varies jointly with x and z, and y is equal to 33 when x is 9 and z is 12, find y when x equals 16 and z equals 22. That's an awful lot of stuff to keep track of, but let's just start with our working equation for joint variation, y equals kxz. And let's substitute the things that we know. We know that y is equal to 33. So in place of y, let's substitute 33. We know that x is equal to 9. So in place of our x, let's put 9 in. We know that z is equal to 12. So in place of z, let's substitute 12. After we've done all of this substituting, we've eliminated every variable except for k. Now we can find k by multiplying 9 times 12 together. That gives me 108k, and dividing both sides by 108. That gives us 33 over 108. Both of those numbers can be divided by 3, so I can reduce this fraction to being 11 over 36. Our constant of variation then is 11 over 36. Now we're able to look at our new situation and find the value for y now that we know what our k is going to be. It says to find y if x is 16 and z is 22, and now we know that k is supposed to be 11 over 36. So let's substitute into our working equation the things that we know. K is 11 over 36. X is 16 and z is 22. Now when I go to multiply these things, notice that the 36 here and the 16 there are both divisible by 4. So we can do a little bit of canceling here from the denominator that we have here to the numerator that is there. 4 goes into 36 and leaves 9. 4 goes into 16 and leaves 4. Now if we just multiply 11 times 4 times 22, 11 times 4 is 44, times 22 would be 968 over 9. That gives us our answer. Y is 968 over 9. Let's look at an example with a word problem, and one that occurs commonly in everyday life with money. Now, this one is simple interest, so it is different than compound interest that we'll see at the middle of our semester. Simple interest varies jointly as principal and time. If $2,000 is left in an account for 4 years, it will earn $320 of simple interest. We want to know how much interest would we get if we deposited $5,000 for 7 years. Well, let's again use our working equation, y equals kxz, since we are told that it varies jointly. Y is going to be the amount of interest that we earn. So in the place of y, I'm going to put interest. Our k is still going to be the constant of variation. X we're going to replace with our money that we know, the principal, and z will replace with time. Changing to these letters makes it easier for us to think about how the problem's going to work. P is principal, so money. T is time. Now, let's take the information we were given, $320, we'll put in for I, since that's the interest we earned. We don't yet know K. Our principal that we started with was $2,000. Let's substitute that in for P. And the time was 4 years. So in the place of time, let's put 4. 4 times 2,000 gives me 8,000K. If we divide both sides, we find that K is 0.04. So this is 4% interest that we're working with when our K is 0.04. Now, our new scenario wants to know how much interest is earned if we deposit $5,000 for 7 years. So let's do that. Going to our working equation, I is equal to KPT. We're trying to find the amount of interest. Our K is 0.04, 4%. We've deposited $5,000 for 7 years. Multiply 0.04 times 5,000 times 7, and we find that $1,400 is the amount of interest that we will earn. Some problems have both joint and inverse variation. For instance, suppose y varies jointly as r and s squared, and it varies inversely to t. If y is 120 when r is 5 and s is 3 and t is 2, we would like to know what r is when y is 80, s is 1, and t is 6. Well, now, as we try to set up our working equation, remember anything that is joint variation will be multiplied times the k on the top. Anything that is inversely will be on the bottom as a denominator. So as we vary jointly with r and s square, let's put r and s square up here on the numerator of our fraction with k. Inverse variation means t will be on the bottom, the denominator of our fraction. Now let's substitute the things that we know. Y is 120, so here I've substituted 120. We don't yet know our k, but we know that r is 5. Here I've substituted 5 for r. We know that s is 3. Here I've substituted 3 for s, and remember that's to be squared. And we know that t is 2. Here is 2 substituted for t on the bottom. 3, if you square it, makes 9. 9 times 5 makes 45. So I have 45k on the top, all of that over 2. Let's multiply both sides of this equation by 2 to eliminate the fraction. 2 times 120 gives me 240, and it eliminates the fraction on the right-hand side. Now we just have 45k on the right-hand side. If we divide both sides by 45, our decimal approximation here is 5.33. That is an approximate value. It's 5 1/3 that we have for our k. The 3's are repeating. Now that we have an approximate value for k, we'll be able to find the answer that we're looking for. We were asked to find r when y is 80, s is 1, and t is 6. So going back to the working equation that we started with, y is 80. Let's put 80 in for y. We now know that k is approximately 5.33. We are looking for r. We were told that s is 1, and remember that 1 is supposed to get squared. And then we were told that t is 6, so the denominator is 6. 1, if you square it, is just 1. So really on the top, we've got 5.33r. It's 5.33r over 6. Take that 6 and multiply both sides of the equation. We'll get 480 on the left, and we'll just have our numerator 5.33r on the right. Divide both sides by 5.33 and account for the fact that we have some round off error here, and our r is 90. When you have joint variation, that will be multiplication of more than one thing with your k. If you have inverse variation, you divide. When they show up in the same problem, things that vary jointly are part of the numerator. Things that vary inversely are part of the denominator. For each of these problems, you'll first need to substitute the information that you know and find k. Once you find k, move on to the new scenario and work the problem from there.